So as Joe said, I'm a developer advocate at loft.sh, and I was a network engineer for 10, 15 years, and 6 years of DevOps engineer, and a couple of years of developer, bits and bobs then and then. And I moved to developer advocate position recently. So in Loft, what we are doing is we have a couple of projects that we are running. One of them is DevSpace. DevSpace, if you haven't heard yet, it's a development tooling kit that you can develop locally and deploy the local copy to Kubernetes. So essentially, you are developing with Kubernetes. And the second one is our flagship is Kiosk, which is virtual clusters, which we will talk about in a minute. And by the way, I'm in Istanbul, based in Istanbul, but I lived in, hang on, let me admit these guys as well. I lived in London for 10 years, so I'm a quarter part Londoner. So this talk's agenda is like this. First of all, we will look at who needs virtualization, or in other terms, in which cases we need virtualization, or we better have virtualization, we can benefit from virtualization. The second one is, can I minimize this? Yes. The second point is current virtualization options in Kubernetes right now, i.e. namespaces. And we will just compare single tenant and multi-tenant options and talk about cost effectiveness of multi-tenant and etc. Then we will steer to virtual clusters, which I am quite excited to talk about. We will explore what are virtual clusters, how they are deployed, and how they can benefit us. And I'm really excited to hear you as well on the topic, whether you see it as a benefit or not, and how do you see the virtual cluster going forward. And then quickly we will have a quick look to virtual clusters where you can run them. And time permitting, we will have a demo. We will deploy a K3s cluster, and then we will install Loft, which will allow us to create new virtual servers, virtual clusters. Sorry. So, who needs virtualization, or which cases we need virtualization? Now, if you need to provide access to multiple engineering teams, like you have three different teams, and these three different teams has dev, staging, and production clusters, right? So that makes 9 clusters. And dev and staging probably load-wise, it's not loaded at all. It's just there for not concept testing, but functionality testing rather. Of course, we can test under load, etc. as well. But in most cases, it will be idle. Another point is testing new cluster-wide resources. This is tricky because if you have already CRDs or other cluster-wide resources defined in Kubernetes, then we won't be able to test the new ones. So either you need to set up another cluster to do this, or you better have a virtualization some sort. And another thing is testing Kubernetes versions. Obviously, we are increasing the versions day by day, and we need to upgrade our clusters like quarterly or 6 monthly. And we need to test those new Kubernetes versions. One option is obviously, again, opening a cluster, creating a cluster, and then destroying it after testing. But there might be more efficient ways to do this as well. And also cost reduction, of course. We talked about the teams, and like dev and staging can be combined into one, or even dev, staging, and prod can be combined with proper isolation and resource quotas. We can allow dev and staging environment quite happily co-inhabit with production environment as well. So I don't see many reasons that we can't do that at the moment, because we have enough technical parameters and functions in place to be able to do that. And lastly, if you want isolation better than namespaces, then again, you need some sort of virtualization. It will benefit you as well. In what I mean by isolation is, it might be again, it might be CRDs, different CRD spaces. You need different cluster-wide resources to be able to configure, and namespaces will not allow this. So the current option, if you look at the current option, what we have in current Kubernetes is single tenant, obviously, no virtualization, complete isolation, complete security, good for security, can use cluster-wise resources without consideration of other teams. That's obvious, but again, if in the same team we have conflicting CRDs or any cluster-wide resource, then again, it might be a problem. Of course, this is expensive, as we discussed, 3 teams, 3 clusters, in total 9 clusters. That's a lot of clusters running and chewing money, really. Also, some folks do CI/CD pipeline by creating the infrastructure first, testing the application or resources on it, and then destroying it. So that it will take a lot of more time if you are doing that traditional cluster way. On the other hand, we have multi-tenant, so all teams share the same cluster. It is difficult to get it right, that's true. Needs good isolation, definitely. We will see how we can get the best isolation from what we have. Of course, namespaces is the current virtualization method that we use. We can assign namespace to each team, and then they can run their pods and everything with them. So when namespaces are not enough, that's the question. It is similar topics, the ones that we discussed before. If you need to deploy Helm charts that configure RBAC, then you need something else, because that will change the cluster's behavior, and then you might get stuck. I mean, you are testing something on dev or staging environment, and you are affecting production. That's not acceptable, of course. If you deploy applications to multiple namespaces, this is a rare case, but I had to write it because I had came across a couple of times. So the database and application is in a different namespace. Then, of course, namespace is not very efficient to do that in a single way. You need 2 different namespaces for the application and the database, of course. But then the team's namespaces increases, etc. And also, if you want to install something that needs to add CRDs, then again, namespaces will not be enough, because they are not namespace, they are cluster-wide. And also testing Kubernetes versions is, again, namespace can't obviously provide that. If you want to do that, you need to either spin up a new cluster or use some virtualization. So how we understand at this point, I hope that is clear. In some cases, we need virtualization, right? As in the simple case that we have dev and staging, we can combine those easily. And because it is a shared infrastructure, and shared teams. It's not complicated to do that as well. So the solution becomes, when we talk about virtualization, solution becomes virtual clusters. So whether we need this or not is again depending on the question, on the answers that you have given on the previous questions. Let's say if we have the need for virtualization, most of the cases can benefit definitely, and let's look at the virtual how they work and how we deploy them. So first of all, we have our VMs and bare metal, of course. Then host Kubernetes cluster. This can be Geeky, AWS, or Azure, or Linode, DigitalOcean, anything you can think of, or you can install yourselves. And this is all good. Where virtualization happens is it is together with namespaces and virtual cluster. So virtual cluster consists of a host namespace and some pods some deployments of a Kubernetes cluster API server, a distribution of Kubernetes, which we are using K3s for this. I don't know if you heard K3s, but it is a lightweight certified Kubernetes distribution. It's built for IoT and Edge. It's a single binary. It is developed by Rancher, and it is very efficient. Single binary, around I think 40 megabytes of 40 megabytes. It is very efficient, and it fully supports, of course, all API calls and scheduling and custom resources, cluster-wide resources as well. So it has two options to run it. One is K3s server, which creates the API server, tunnel proxy, the SQLite database to so that API server stores in SQLite. This is done because on edge cases and IoTs, SQLite is quite sufficient and fast enough, actually. And in this case, if I remember correctly, we can introduce a proper etcd as well, but at the moment, SQLite is quite sufficient, what we see. We have control manager on K3s server as well, and scheduler as well. On the other side, K3s agent, if you run it with agent parameter, it will open kubelet, the container D, and then it can act as a node rather than server. So left-hand side is the master and right-hand side is a worker node. Now, this diagram actually shows us a good deployment of a virtual cluster. Now, the host cluster is at the bottom of all of these. And the namespace My Virtual Cluster 1 is part of the virtual cluster. And in that, we have a pod. We have two containers in that pod. We have K3s as the API server and the other components that needs to be long-standing Kubernetes deployment. And the other container is the Syncer. Syncer's job is, let me take you a couple of steps back. So K3s, we are, yes, deploying a Kubernetes distribution, definitely, but we are disabling some of the features of it, like the scheduler or the node lifecycle agent, agent altogether, network policies. These are not, we don't need them, because what we want is virtualization, and best most effective way to do it is let the host cluster schedule the pod, but it will show as running in my virtual cluster one. So what I mean by that is your objects, pods, services, config maps, secrets, PVCs, endpoints, ingresses, all these will be synced into the underlying infrastructure, underlying host cluster. So you can share some of the resources as well, which is very nice, like ingress. You don't need to assign another IP and another load balancer to it. You don't need another ingress rule set up. You can use the same ingress for the host and the virtual cluster as well. So Syncer's job is actually taking these components. So we have the API server. We are talking to the API server. We are telling we need a deployment. We need 3 replicas. We need this image. We need these environment values and request limits, etc. These are all written in the API server and the database. And Syncer sees these changes and then starts initiating a process that schedules the pod actually in the host cluster. So from virtual cluster point of view, of course, it is our pod. It's running on our namespace. We have namespaces as well, of course, in virtual cluster. And we have all node resources, like we can see the node as well. And K3S, because it's a full distribution, it is very efficient to drive forward. You can change the versions even for testing purposes. Let's say I think we are currently deploying 118 by default, but you can easily change to 119 or 120 so that you can test your objects in 120 Kubernetes distribution. This is how we run K3S with server option. And as you can see, there are disabling many services like traffic, service LB, metric server, local storage, network policies, agent, scheduler, cloud controller. We don't need any of these. We need a good API server, good storage. We need to understand what the user is trying to do. So Kubernetes distribution will take all the objects, accept them, and then try to schedule them with the host cluster via the Syncer. And of course, we can share some resources between the host cluster and the virtual cluster. And these consist of monitoring, networking, storage, backups, and admission controllers, ingress controllers. That's one very important one. Ingress controls are shared by default, but you have the option to disable that sharing as well. So they can actually create an ingress using the ingress controller, a separate ingress, separate external IP, and complete isolation. Essentially, you can deploy virtual clusters anywhere. So it doesn't matter whether it is Geeky or AKS or EKS, DigitalOcean, Linode, etc., Alibaba Cloud. So any Kubernetes distribution, because we are deploying a pod on a new namespace, and that pod is running Kubernetes. That's all what we are doing. And then we have a Syncer process. Syncer process is actually getting the objects and trying to consolidate the actual topology with the given object. So if you want 2 replicas of a certain pod, you get 2 replicas of a certain pod. But the scheduling is done by the host cluster, so it is efficient. Yes, demo time. Now, welcome to our demo, and we will explore virtual clusters and how we can install virtual clusters, create virtual clusters, destroy them, and also we will see the loft CLI and the loft UI as well. So for loft CLI, we need to go to loft and click get started. Select your shell and copy. Now it is downloading the binary, asking for a password, so it can copy it to user local bin. Excellent. Loft CLI is installed now. I have a local cluster, Docker desktop cluster, ready and running. It's running 1.19.7. There is not much on the default namespace. It is only installed on the metrics and some DNS, I think. That's it. And let's do loft start. To start the loft, it will ask us how we connect to the cluster locally or remotely. It tries to detect this and asks anyway, because sometimes it can be misleading. I click yes. I select yes and it wants email. I just type my email address for the admin user. Now, as you see, it is executing command helm install loft. Repository is our repository. Kube context is Docker desktop, namespace loft. You can change these parameters as well if you wanted to create namespace different than loft. For simplicity, we accepted all the defaults at the moment. Now, at the moment, it is installing. Let's clear this old session. Get namespaces, as you can see. And loft CLI is installed loft and kiosk into the host cluster. We have some services for them, of course, and separate deployments of them. And now we should be good to go. Excellent. We will log in to Loft first via this CLI, and it will open a web page. Here it is just telling cert authority is invalid. Just proceed. Login, admin, and the username, password provided to us. It will ask a couple of questions like our first name, last name, etc. Finish the setup. Voila! Now Loft is installed. Kiosk is installed into the host cluster. As you can see, we can see the Loft namespace. Kiosk and Loft is installed. We can see the logs for the kiosk and also Loft as well. Excellent. So now virtual cluster creation. So let's create a virtual cluster called London. Here you can set advanced options. You can change the version of the Kubernetes deployment and the CIDR for services, and this you shouldn't change, of course, and that should come as it is. Now it is creating the virtual cluster, containing creating state and running. Excellent. Pretty fast, huh? And now I needed this. Don't need it. and get context, let's say. Now we have Docker desktop. Okay, that's excellent. So how we connect to this virtual cluster now? Let's connect to the virtual cluster with your loft CLI command. So this will actually create a kube context for us. Oops, login didn't work apparently. I think that was a problem. Yes, login is successful. Loft use vcluster London, cluster loft cluster, which was the given name to our base cluster, host cluster. And the space name is virtual vcluster London, which is the namespace. So let's do get nodes. We should receive the nodes of the host cluster. So Syncer works both ways. This cluster-wide resource, i.e. node, needs to be synced into the virtual cluster. If we deploy anything on the virtual cluster, like deployment and pods, that needs to be synced into the host cluster as well. Okay, so it's a both ways. And excellent. Now, here you can actually install any apps you want from the Loft UI, which is quite easy. So it runs Helm at the back end. Now, let's say I have created 2 YAML files. One is deployment and one is SVC, the service for an Nginx deployment. Now I'm applying those pods. It's running already. Excellent. Let's see logs. Usual stuff. Port forward 8080 to 80. So this is Nginx running on our virtual cluster, which is running on our base cluster. Okay. So if I do localhost 8080, I'm seeing Nginx. Perfect, as we expected. We have done our port forwarding as well on top of this, and everything is working as expected. So if you want, let's explore the virtual cluster components. Okay. Now we have vcluster London, which is the base. If we look at it closely, we have core DNS in the kube system namespace of that virtual cluster. How do I know that? This is the pod name, then X, and namespace name X, cluster name. Nginx, again, default namespace in the London virtual cluster. Okay, excellent. So we can see our pods, we can see our services here in that namespace. Space. Sorry. So as you can see, deployments, we don't have any deployments here. We have the Nginx deployment is in the virtual cluster. We are just looking under the hood, okay? If it seems a bit confusing, don't worry. You get your head around with it quite easily. We are looking under the hood of the virtual cluster at the moment. So we saw Nginx deployment and the Syncer and the Kubernetes deployment, which is here on this pod. Switch the context. We have the deployment here, but pod is synced, okay? And if there is any changes on the deployment, it will be synced to the pod as well. All right, everything is working as expected, and this is the demo for the virtual clusters. Now I can do I can configure my virtual cluster with CRDs, install other applications, and then destroy the virtual cluster. As in namespaces, all the resources will be destroyed. Okay, that's quite pleasant to use, easy to use. And let's say we are destroying this namespace as well. Yes. Now get namespaces. Yep, that's gone. So we have destroyed the virtual cluster in a few seconds. We open the virtual cluster in a few seconds. This is pretty good and pretty fast way of managing virtual clusters. Again, it's creating a new one, London 2. It's already running. Let's see pods. There's no pods running yet. Up, coordinates came on. Excellent. These are the namespaces of that virtual cluster. And we can create users from here so that they can use Loft to create virtual clusters or spaces as well. All right, this is it for now. And tune in for more advanced demos and presentations. Take care.